All right. Mm.
Why the number is shrinking? Why you're not all the learners are attending the academic counseling? I think because of this timing.
I suppose the
Looking
timing
great,
doesn't suit.
Tanima. Looking
Yeah, yeah.
great.
Thank you. Uh, I can start, or should I be waiting for 2 more minutes?
I think we can actually do, these days are weekdays now. So many of them who are working they join a bit late.
Okay, so I suppose I can
But
start then.
you have to start because we can't
Ah,
wait too much.
yes,
But
right.
you can still wait for 2 more minutes.
Okay,
And I'm starting the recording. Okay.
I have already started it.
Okay, that's great.
Yeah, I've already started it.
So, learners, I know you have so many doubts regarding the processes, assignments. I think doubts are clear, but for examination and re-registration, you are having doubts. So, I have organized a grievance redressal meeting on first. I'll send you the link soon. So, but I just want to tell you that you don't need to worry at all. University is taking very good care of for all your further examinations and re-registration things. So please don't worry. And you can contact me. Some of them are contacting me. I'm trying to resolve their queries. But face to face, we can meet on first. And time I'll tell you. I think it's around 2 to 3, but I'll confirm and tell you through email. So now stage is yours, Tanima, and
Thank you so much, Dr. Gargav.
I
Okay,
think
so
all of the learners are very well. You're already
yeah, I'm
having
already a
old
part of
all
the family.
yeah,
Yeah, I'm
yeah,
already
yeah,
a part
yeah,
of the family now.
and it's going to be a long journey,
Yes, hope so.
definitely.
Right. Fine. So again, a very good evening to all of you, people who have joined a bit like in the after 6:30, and
Okay, one suggestion is there when you do discussions, you in Google Meet, it's not possible. Sometimes echo is so much, so you can ask them to type on the
okay,
chat box.
all right, fine. Yes, so fine. You have heard Dr. Karagrav saying that. So if you people have any issues, you can obviously always type in your things, or you can always like just open your mic so that I'll know that somebody is speaking, and I'll put off my mic and I'll take your queries. Now, before I move on, like just a very short recap of what we have done so far. So we started off with the basics of statistics. That is from where we started off, and then we saw what is the collection of data. We saw how like what are the various sources of data. We looked at into the classification of data, which is very very important. That how you classify your data, and then a bit of graphical things we saw to it, and we then moved to central tendency dispersion. In central tendency we saw basically mean median mode. I did not go into quartile, decile, percentile, though I just gave you a very very yeah, Bidisha, if you can just close your mic, or I'll do that. Okay, right. Yeah, so as I was saying that we went through that, we saw what the measures of central tendency are. Basically, your mean, median, mode we saw, and The rest of the things, as I was saying, that quartiles, deciles, percentiles, they are very similar to median, because they also tell you the location. Basically, that is the basic work of all these things. They are as good as your postman. They just tell you the address. Generally, they don't tell you much more than that. And mean is one measure of central tendency which is used the most. The reason, like, though it has got its own limitations as well. Like, I mean, for mean we have to have normal distribution. So today, when we'll be talking about the probability distribution, so we'll be talking about those normality, that how you check normalcy of the data, and all those things also we'll be talking. um so yeah, and another very major problem with mean is about the outliers, that because it takes into consideration all the observations, so that problem of outliers is always there, because mean very much gets influenced by the extreme values. Many a times, like when your observations are too large, and if you've got very few outliers, a lot of times we say that you just drop the outliers and then take the average and then go ahead, because otherwise your future calculations gets affected. Because we then saw dispersion. In dispersion, basically we were talking about range, which is again not a very useful measure of things. We saw two things in detail. One was the mean average deviation or mean deviation. And the second was a standard deviation. And I told you that why standard deviation is standard. If you remember that mean plus minus one standard deviation covers 68% and 95%, 99%. Yeah, so we discussed that in great detail. Uh, Standard, basically the only, like, what standard deviation went ahead and did, like, the base, the you can say that the base was laid down by mean deviation. But because mean deviation takes the modulus, so when you're taking the modulus, obviously you're ignoring the signs. And statistically or mathematically, that doesn't sound to be a very good method, because if you're ignoring the signs, because signs tell you a lot of things. Like, about the direction of your data, or the relationship. So therefore, to correct that in standard deviation, again, you're doing the same thing. Like, you are doing away with the signs, but you're doing it in a more statistical, or math. I shouldn't use the word statistic. In a more mathematically correct way, where you are taking the squares, and then you take the root of it, so that you bring it back to the same base. So that was about standard deviation. And then in the last class we talked about correlation and regression, and I said that correlation, basically, though, like in a lot of books and everything, we always read about correlation as showing the relationship. Mm, I said, I use the word association, because I think so. That is what it shows. That is what correlation shows you. It shows you the association between the things, rather than showing the relationship. Because uh, okay, to an extent, you can say the relationship is also seen, but uh, it's the heart is with regression. Like, if you understand regression, then you understand a lot of data analysis. You understand a lot of statistics. Of course, you people are doing your masters in business administration, so you people don't study econometrics. For us, people from economics background, we do a lot of econometric modeling. And for us, regression is the thing, because if you understand the basics of regression, then all the future models are based on regression. So बहुत सारे models निकल कर आते हैं regression से, तो इसलिए regression समझना बहुत जरूरी है. ये जो हमने पूरा पढ़ा, like all those things that we have studied, any doubts, any clarifications you people want from my side, anything that you feel that I should be telling you? You can type in your queries as well, because I can read that. I've still not moved to my PPT, though it's there on your screens, but I have not moved there. So, uh, if any questions, any doubts, anything, or a submission, you might have felt that I have not done justice to a topic, kindly go ahead. नो क्वेश्चंस। इसके दो ही मतलब होते हैं। हमारे जो गुरुजी थे वो हमेशा कहा करते थे कि दो ही लोगों के पास सवाल नहीं होते हैं, एक जो अत्यंत बुद्धिमान होते हैं और दूसरे जिन्होंने कुछ पढ़ा नहीं होता है। तो अब आप अपना क्लासिफिकेशन कर लीजिए कि आप किस क्लास में आते हैं, विच क्लास यू
Hello.
बिलोंग टू। यस, या विदिशा, गो अहेड।
Okay, yes, ma'am. I just wanted to say that can you please do a recap on regression because it is important topic. Right.
I was just starting that, Vidisha.
Okay.
Anything before that? Anything before that?
Now, I think we were supposed to do numerical on
Yeah, we were.
regression.
Yes,
Huh.
we were.
Mhm.
So I'll let me
Okay.
start there. All right.
Okay.
ठीक है, thank you. Okay, fine. So here we were, and just a very, very like.
Tanima, our regional director, Dr. Binny Toms, is also here.
Okay. Uh,
So,
yep.
ma'am, if you want
Yep.
to give your blessings, you can please talk to our learners.
Hello, ma'am,
Hello.
and greetings to all our learners from IGNOU. I will not like to disturb the session, so all my best wishes for your studies and for the session. Please go ahead with the program.
Thank you so much, Binny ma'am. Thank you so much.
Thank you, ma'am.
Thank you.
All right. Let me. I already have a numerical here with me, and let me just go full screen so that it becomes a bit easy for us to understand. Now here, this is the data that we have about cigarette consumption and chronic heart disease. So what regression basically does is that, let me just add a few blank slides. Uh, just a sec. Okay, so what basically your regression does is that it is we are showing the causality, right? So so that cause and effect relationship we are saying. So we said that you have got a dependent variable which is a function of an independent variable. So to explain it further, we say that it is y is equal to a plus bx plus e. Or in many books, you'll read this as y is equal to alpha plus beta x plus e. In a lot of books, you will read it as beta naught plus beta 1 x plus e. So it's one of the same things. Now, very quickly, let me give you a brief reminder that a is a is the intercept. Somebody's mic is on, please close it. And b is the slope. B measures the slope of the regression line. It so we generally use here what we are using is OLS, which is your ordinary least square method. We are using the ordinary least square method. Now, in the ordinary least square method, you can always estimate your A and B by using simultaneous equations. So you can use simultaneous equations and you can calculate the value of A and B. Now, what is E? E is your error term. And the objective of ours is to keep this error term as small as possible. That is what our aim is. So what we do is how do we calculate our error term? So it's y hat minus y. So basically your estimated value minus your actual value. That is how you calculate your error term. And as I've said, that we want it as small as possible, because that means that what we are trying to see is the goodness of fit. So this goodness of fit will depend on how well the data is fitting there. Now here in the what we are taking, the example that we have taken is that your we are taking cigarette consumption, and we are taking cardiac disease. So we are saying that now, which will be the dependent variable here? Just open your mic and very quickly tell me that which will be the dependent variable and which will be the independent variable.
Dependent is cardiac.
Okay. Okay, so this will be your y and this will be your x. Right. So, right. So what we have here is we have, as she very rightly said, that cigarette consumption is your x, which is your independent variable, and this is your dependent variable. So this is independent variable, this is dependent variable. Now, what we have done is we have estimated mean, we have estimated the standard deviation, and from there, like, we have calculated the mean for both. We have calculated the mean of x and mean of y. So how do you calculate? X bar is equal to summation x upon n, and similarly y bar is equal to summation y upon n. So you just do the total of this. If somebody can do that very, very quickly, it's 20, 29, 38, 46, 54, 62, 68, 74, 84, 94, 104, 108, 12, 16, 125? Is the total coming out to be 125?
Yes, ma'am, it is 125.
Okay, so 125 by 21, so that will come out to be 5.95. Similarly, if we do it for these, it'll come to 47, 67, 71, 72, 92, 102, 111, 114, 124, 34, 43, 143, 144, 154, 154, 154, 174, 177, 177 plus 10 is 187, 192, 192, 202, 205, 207, 217, 225, 225 plus 12, 237, 240, 251, 261, 266, 272, 272, 275, 285, 285, 289, 299, 303. Is this coming out to be 303? Three not four. Yeah, 294. 294 ki 304? Mm.
मैम 305.
हाँ, चलो 305, एक खा गई मैं. 305 and divided by 21, so that comes out to be 14.52. And similarly, you can find out the standard deviations. So standard deviation is what? Summation d square upon n, the whole under root. So if you remember, how do you find out that? You can like I'll just do it here, one like x minus x bar. So x, your 5.95, so you can round it off as 6, and you can round this off as 15. So you just do nothing, but you do here 11 minus 6, 9 minus 6, 9 minus 6, and so on. Similarly here you just deduct 15 from here, and then whatever you are getting, just square this up, so say like the first one will be 5, then 3, 3, 3, 2, 2, 2, and then you square it up as 25, 9, 9, 9, 4, 4. I suppose you people got this. You got how to calculate this. So once you have calculated your standard deviation, so you have your standard deviations which are given here, right? Now, let me just remove this. Once you have done this, then you can find out, like this is also one way of doing it, and you get your like this is the standard error that we are finding out. Once you have done that, you can then estimate the value of you can we found out from a covariance method is there, the correlation standard, correlation standard deviation by standard is there, and then n summation xy summation x, this method is also there. So it's up to you which of these methods you want to use. Like for me, I prefer this method because for me, I find this a bit easier to do. So I use this method, and or like simultaneous equation methods are also there where you can use it. And simultaneous equation का method का formula क्या है? What's the formula for that? Hmm, I hope I remember the formula. Uh, it is mm, I think so. I'm telling you the right formula. This is the formula. This is the simultaneous equation formula. Uh, just I'm putting this reason I'm putting a star is I hope I'm telling you. I suppose this should be summation y square. This should be summation y square. And from memory, I'm just recalling and telling you any of the methods, whichever suits you. So, because the sum is a bit numerical, is a bit big. So let me take a very small one and just show it to you that you take your x as say 1, 2, 3, 4, 5, and then you take your y as and we can just take the means here, and we can or we can take xy, x square, y square. So this will be 26, 48, 69, 76, 90. 1, 4, 9, 16, 25. Y square will be 24. 19 square is 361. 18 square is 324. 23 का कितना बनता है? 269. 244, 269. Yeah, 269. 24 is square is what? 286. 4 into 24. 576.
570.
हाँ. And I suppose ये भी मैंने गलत लिखा है. 23 is not so less. 23 into 23 is 529. I need to brush up my squares. 676. So we can just find out the totals here, and you people can also do it on in your copies. And so this is 279. This is 14, 30, 30. This is 55, and then 676 plus 5. I have written this wrong, I suppose. ये कैसे possible है? 24 into 24, 576. 529. Somebody was telling me the total of what? Of this? 9 plus 361 plus 324. 2466. So you have this the formula that I just told you, that summation xy is equal to na plus b summation x. Summation y square is equal to a summation x plus b summation x square. So summation x y comes out to be 279. N is 5. 5a plus b summation x is summation of x I have not done. So this comes out to be एक second. I'm just having a few doubts regarding the formula. So let me just confirm. There's no point of doing all the calculations and telling you people the wrong formula. Just give me a sec. Regression. Yes. So sorry for this, and but I always believe that it's better to take our time rather than doing it wrong. It's just okay. ठीक है, let me just write it here. It's summation y is equal to na plus b summation xy plus a. Okay, उल्टा ऊपर नीचे कर लिया मैंने. Let me first share my screen. This is wrong. Okay. So we write summation y is how much? 50 plus 20, 50. This is coming out to be 110. So 110 is equal to 5. 5 is n is your number of observations, right? So in this case, it is 5. So 5a plus b summation x r came out to be how much? 10, 10, 14, 14. So this is 14b. Xy is 279 is equal to 14a plus 55b. I suppose all of you know how to solve the simultaneous equations. You can solve this. I suppose all of you know how to solve this. Somebody very quickly can say a yes or a no.
Yes, ma'am.
So just please solve it and tell me what is the value of A and B coming out. You can do cross multiplication, like you can multiply this entire, the second equation by, this can be multiplied by 5 and this can be multiplied by 14 so that you get a common number. And a lot of people from mathematics will say that this is too long a method, but of course, then whatever suits you, you do that. That comes out to be 1540 is equal to, yeah, somebody got the answer, please let me know. Somebody put on their thing. So I'm writing it here, because I can't write it there. So it's coming out to 144 and minus 275 minus 196. This is coming out to be B. So value of B is 145 upon minus 79. So it will come out to be 145 divided by 79, 1.83. So this is coming out to be minus 1.83. Are you people also getting the same value?
Yes, ma'am.
So now from here, you can tell me the value of A. Just substitute the value, like it's 110. Rather, I should be using another color pen. This is 110 is equal to 5A plus 14 times minus 1.83. So this comes out to be 110 is equal to 5A plus 14 into 1.83, 25. 20, this will now become minus because you've got a minus sign here. So this becomes a minus. So 25.62. I would have got 0 marks for neatness. 110 plus 25.62 is equal to 5A, which makes it 135.
16.87, ma'am.
Thank you. A is equal to 16.17. 87. Okay. Okay, thank you. So now your equation is this. Your equation is what? Y is equal to A plus B X plus E. So Y is equal to the value of A that we got is 16.87 minus, because the value of B is minus. So that is 1.8383x plus E. So this is your regression equation. This is your regression equation. Now, by looking at the value at the sign of B, the sign is coming out to be negative. The beta value is getting negative. So will you have the regression line will be positively sloped or negatively sloped? The regression line will be positively sloped or negatively sloped. Your beta value is negative. थोड़ा सा दिमाग लगाओ. बीटा की वैल्यू नेगेटिव में आई है. Beta is your slope, right? I had told you that it's the slope of the regression line. So will you have, let me just very quickly draw it for you. Will it have this or will it have this? Which is the right answer, A or B? Which is the right answer, A or B? रॉकेट साइंस नहीं है, थोड़ा सा दिमाग लगाओ.
बी 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 है, बी है,
बी है, बिल्कुल सही है. किसने बोला?
डाया भाई.
हाँ, absolutely right. Very good. This is the right answer. You'll have a negatively sloped because your sign here is negative. So that's the reason you'll have a negatively sloped. Now, you have estimated y. How to calculate y hat? How to calculate y hat? Madam बताएंगी. Okay, just again a second. Huh? Okay, so now here you have got your somebody just prompt me the y values, x and y. X is 1, 2, 3, 4, 5. Please tell me the y values, somebody.
26, 24, 23, 19, 18.
Okay, thank you so much. Your equation is y is equal to 16.87 minus 1.83x plus e. Now what we'll do to find out the value of y hat, we'll use this equation, and here in this x you will be substituting the value of xy till x5 because you've got 5 values of x. So from x1 to x5, you're going to substitute. That means it'll be 16.87 minus 1.83 times 1. 16.87 minus 1.83 times 2. 16.87 minus 1.83 times 3. You can start calculating and you can then tell me the results. Times 4, and 16.87 minus 1.83 times 5. And somebody can just prompt me the answers.
That's 15.04,
Hmm.
13.21,
Hmm.
11.38,
Hmm.
9.55,
Hmm.
7.72.
Thank you so much. So, any doubt? Any doubt in this? How we calculated this? Any doubt?
No, madam. No, madam. It is clear.
Chalo, ठीक है. Thank you. Now you have calculated your y. So this is your this is the actual value. This is the estimated value. Now you have to calculate your error term. Error is what? Y minus y hat or y hat minus y? E is what? Y minus y hat or y hat minus y? Which is correct? This is A, this is B. Which is correct? Hmm? Sorry?
Is it B, ma'am?
You're asking me? Chalo, let us see. So we are saying y minus y hat for any x is the error of estimate or the noise or the residual.
Estimated
So
value minus actual value.
no, y minus y hat. मैंने उल्टा बताया था क्या?
Y hat minus y.
That is what I told you. So sorry, it is y minus y hat.
Okay, ma'am.
Yeah, please correct it. I might have because मैं भी confuse हो जाती हूँ बहुत. So this is y minus y hat. This one is the right. Okay, this is the right one. So अब जरा ये बताओ, माइनस करके बताओ. Hmm. Fine. This is y minus y hat. All right. Done.
Yes, ma'am.
Okay. Now, here after you have calculated this much, you have calculated, we estimated our error value. Then what we can calculate is the standard error, right? Like from the once you have calculated the residual, you can then estimate your like you can make predictions. Basically, this y hat that you have calculated is a prediction. Okay, that is a prediction that you have done, and your intercept is 16.87, and the rate of change, like this 1.83 that we have calculated here, is the rate of change. That means if 1 unit of y with 1 unit change in y will lead to 1.83 change in x. तो इसको हम ऐसे भी बोल सकते हैं, like if I want to interpret this, so I'll say that one it was what, cigarette is a function of, sorry, d is a function of, how can cigarette be a function of chronic heart disease is a function of cigarette. This was our thing. So if we are saying that if you smoke, like if you like the rate of change is 1.83, right? So one cigarette will lead to 183 increase in CHD, right? Though because this was my data that I took is not a correct data, so that's the reason we are getting a negative sign here. Otherwise, in this case, in case of a cigarette and a chronic heart disease, it should be positive. It cannot be negative, because cigarette does lead to heart disease. Is this much clear? Is this much clear to everybody? Everybody, is it clear?
Yeah, madam, it is clear.
Okay. So this is now what happens is that in regression, what we are doing, we don't, this is binary regression that we did. Normally we don't do binary, like normally in the sense like, अब जैसे आप Monica, you are you told me which sector you are from?
Yeah, madam.
You are working in which sector, Monica?
Not understand, ma'am. Why?
Which area, which sector are you working in?
No, madam. I'm.
Actually, you're not working.
Yeah,
Okay.
yeah.
Okay, right. Akshay was in Akshay, you were in logistic.
No, ma'am.
Who was that? Who was in logistics? Somebody was there in the class. Akshay, you were you are in which industry?
So, ma'am, I'm working in engineering. I'm an engineer right now.
Okay,
So, I've
and
done logistic regression.
do you Akshay in engineering, what sort of projects do you people do?
Ma'am, I've done logistic regression and analytics basically. So, I understand in that sense.
नहीं, what I'm asking is logistic regression तो ठीक है.
Yes,
I'm
ma'am.
asking you that as an engineer, what is your like area of work? Like what do you do actually? What are you doing?
Actually, I work in a solutions company. It provides software solutions. Like there are different kind of softwares that we work in,
Uh-huh.
like in different languages. Basically, my work is in Python.
Okay, all right.
So through that, yes, ma'am.
Okay, chalo. So अब ये like if we take Akshay's example, that Akshay is doing like they are finding solutions. So the use of a software, like say use of Python. Now use of Python depends on a lot of things, right? So if somebody, say for example, of course Akshay's company might not be doing it, but say supposingly that when if they are providing solutions to the softwares, and they are teaching the software as well, okay, or they are trying to train people in the software. Now the training in Python is a function of a lot many things. It depends on that who wants to learn, how much are they charging for it, how much, what is the duration of the program, what is the cost of Python? Like if somebody wants to buy the software, so how much is it? Is it of open sourceware? Have we to pay for it? So there can be multiple reasons to it, multiple factors that can be affecting it. So what we do is normally, like what you people will be doing is using multiple regression. So in multiple regression also the fundamental remains the same. So it's like you have to like here we found out one beta value or one slope. There you will be finding like every independent variable will have its own coefficient. Here, because we had just one independent variable, so we had just one coefficient. In that case, we'll be having, because you'll be having multiple independent variables, so you'll be having multiple coefficients there. And you've got n number of softwares to do it. You've got simple Excel can do it for you, SPSS can do it for you, SAS can do it for you, Stata can do it for you, R can do it for you, any there are a mini tab can do it for you. So there are so many softwares which can do it for you. I suppose Python also does it for you. I don't know how to use Python, so I can't say, but I think पता नहीं, शायद Python करता होगा. I don't know whether Python can estimate that or not. Now he used the word logistic regression. Have anybody heard of this logistic regression? Though it's not a part of your syllabus, just ek jabran ka gyan. What happens is that if your dependent variable happens to be a binary, or happens to be a categorical variable, like say supposingly I want to find out I want to find out the impact of training on like I want to find out the impact of training on the productivity of farmers. Like if we are giving training to farmers, is their productivity increasing or not? So I can have an answer to training as yes or no. Like I go and ask people that, did you get a training? So they answer it in yes or no. So if this sort of a problem is there, then we use logistic regression. Within logistic regression also, like there is logit, there is probit, there is tobit. There are three things. Then of course, using probit and probit and logit, we can go for futuristic like forecasting methods. तो वो अपन उसमें पढ़े ही नहीं. So basically what here we were doing, I suppose it's clear to everybody, so I'm not going to waste any more time here now. Now what I'm going to move to is probability. That is what I'm going to shift to. And let me very quickly share my PPT again.
Ma'am,
Yes, yes.
like what kind of regression do we have to do, like in order to prepare ourselves, like at present?
तुम लोग तो बस बाइनरी वाला यही वाला सीखो, ये जो बाइवेरिएट, जो
Okay,
the
ma'am.
one
The
that we
one we
did
do
right now,
right
the
now.
one
Okay,
that we did right now, that is just
okay, ma'am.
sufficient for you.
Thank
For
you. Thank
passing
you.
the exams, that is more than enough.
Okay, ma'am.
Right. You know, as a teacher, we बहुत बार होता है हम ना थोड़े से ज्यादा बह जाते हैं. मेरे साथ तो खासकर बहुत हो जाता है ये. Okay, so we'll be talking about probability and probability distribution. Now, all of us know what probability is, and I suppose I don't know about others, but I, as a student, found this to be a bit tricky. I never liked it, but now in econometrics, I'm using a lot of probability, so I had to learn it the hard way. Was never my favorite topic. So probability is basically people here, a lot of engineers are there, so they know it so much better than I do. It's the chance of something happening or not happening. So it's something is occurring, something is not occurring. So that is what probability is. And of course, probability distribution will be looking at. So here you have got binomial, you have got Poisson, you have got normal distribution. So these three we study. So let's start with probability. So we say that it's the likelihood or chance of a particular event will occur or not occur. So that is what it is. And like it is all about uncertainty. Like when you're talking about probability, you're trying to find out about the uncertainty that is there, and it gives you a quantitative measure of different events, and it always ranges between 0 to 1. So probability will never go down from 0, or it will never go above 1. This is not possible. Both these scenarios are not possible. So it is always between 0 and 1 that probability moves around. If your probability is p value is coming out to be 0, it means what? And if p value is coming out to be 1, it means what? If p is 0, then what? Something is
No
going to.
probability.
Yes, exactly. मतलब होगा ही नहीं. Okay, zero probability of something happening. So if somebody is sitting in Bhopal right now, so there is zero probability of getting snow. Somebody's sitting in Kashmir or Himachal, the probability of getting snow is like it can be 0.2, 0.3, it can be. So 20%, 30% probability may be there, because like Kashmir received a snowfall a few days back. So this is the interpretation of 0 and 1 here. Now, these are some very, very important concepts and some terms that you need to remember. People who are already familiar, it's just a recap for you. People who are doing it for the first time, you need to pay attention to these things. So you've got an experiment. Experiment is the process which will give you some results. So if you're doing anything, so if I like, of course, this is a very hackneyed example, but we use it. So we talk about tossing a coin, rolling a dice, taking out cards from a pack, taking out balls from a bag. These are very hackneyed examples, but of course, the experiment can be what? Uh, Injecting cove in somebody with like if you're injecting cove, so that is like that is an experiment that you're carrying out, and then you see that what is the probability of getting COVID after this. So is it like, is it zero probability? Is it one probability? Like right now we know, after suffering for almost like more than 2 years since we have had the corona. So we now know that even with a shot, even with a booster dose, there are people who are still getting the virus. So the probability is, of course, not zero. It is also not one that if even if you get a vaccine, you will be getting corona. No, but yeah, there's some probability of you getting a corona, so it's not zero. So this is an experiment, and then the event that is happening now. Event is the possible outcome. So the possible outcome of injecting COVID is like, if somebody is injecting, it was COVID only that we were getting, or one was Covishield and the other was what? COVID? यही था?
Covaxin.
Covaxin. ओहो, बताओ, मैं भूल गई. Okay, so Covaxin was there. So if you're injecting Covaxin or Covishield, whatever you are using, and then whether you get COVID, do not get COVID. So these two are the outcomes that you are having. So this is called an event. This is your event, and of course, this is the experiment that you are carrying out. In case of a coin, tossing the coin is the experiment that you are doing. Getting a head or tail, these are the events that can happen. Then independent and dependent variables, so events. So if two events, of course, if the occurrence of one is not dependent on the occurrence of the other, then it is an independent event. And of course, if the occurrence of one is dependent on the other, then it's a dependent event. So if I'm tossing a coin, and I toss this coin, like I'm tossing a coin uh, 500 times. So uh, each experiment will have two outcomes. Will these outcomes be independent or dependent?
Independent?
Of course. And give me an example of dependent. It'll be independent because एक बार का head, मान लो like I tossed a coin and अभी मेरा head आया और अगली बार फिर से head आया, so the second head is not dependent on the first head, of course not. Yeah, give me an example of a dependent event. अच्छा. uh yeah, somebody.
Yes. I'm like, there are two balls in a bag, red and blue.
Hmm.
If we, get red ball in first chance,
Hmm.
so there is only, we know that there is only, the other color ball left in the bag, and then there is a surety to get the, you know,
The
that
blue
color
ball,
ball
the blue
out
ball.
from the bag, right? Blue ball from the bag.
Absolutely right. I was just giving you the example of cards, that if you are in a stack of cards, if there are 52 cards, I pull the first card, I get a ace, I get an ace of hearts, and I do not place it back. I do not place it back here. I am then left with 51 cards. Then the next one will be dependent because of course I've already pulled out one card, so the एक card kam ho gaya hai. So then the next one will be affected. Whatever I'm pulling out will be affected by the first one because I won't again get a ace of hearts, or as he very rightly gave an example. Then you have got mutually exclusive coins, mutually exclusive events, mutually exclusive events. Uh, it is mutually exclusive means that only one event can occur at a time. It's when only one event can occur at a point of time, then we say that it's a mutually exclusive. So if the occurrence of one implies that the other cannot occur. So if I am tossing a coin, both head and tail cannot happen. If I got a co-vaccine and then it cannot be that I'll get both COVID and not have COVID at the same time. I'll have either COVID or I won't have COVID. I'll either get a head or I won't get a I won't get ahead. So this is mutually exclusive events. So this is very very important. Like when we do the numericals, then this becomes very very important. Then comes the exhaustive events. Exhaustive means the word exhaustive in itself means that when you are reaching that limit, like it's the exhaustion of something. So getting exhausted or getting to the threshold, getting to the limit. So the total number of events that are possible from an experiment is known as exhaustive events. So whatever, like if you're tossing a coin, there are two possible things. So that is the exhaustive. If somebody. क्या हो गया था? अच्छा, हाँ. So as I was saying that the total number of outcomes that are possible are known as exhaustive events. So like a coin, only two is possible. If you are rolling a die, then there are six outcomes that are possible. If it's a card from which you are doing 52 other, so the total number of possible outcomes that you can have, that is exhaustive events. Uh, Equally likely events, if you're talking about the equally likely events, then uh, when both or like all not both, when all the events have equal chance of occurring or not occurring, so then that is known as equally likely event. So like if you're tossing a coin, there is equal chance of head and tail, so it's 50-50, or like it's like p is will come out to be 0.5. If you're rolling a die, if you're rolling a die or tossing a die, dice, or a die, however you want to say it, what will p come out to be in case of equally likely event?
6.
6. 6 कैसे होगा?
I think 6 into 6,
36.
I guess.
तुम ये लगा रहे हो?
I mean, मैं ही लगा रहा हूँ, like when आने का chance is like 6 times.
नहीं, इसकी प्रोबेबिलिटी क्या है? हर की प्रोबेबिलिटी कितनी है?
हर एक की probability like अगर मैं one time अगर मैंने dice toss किया तो एक ही probability होगी ना?
नहीं, एक कुछ, यू विल गेट ओनली वन म्यूचुअली एक्सक्लूसिव है, मतलब आपको कोई एक मिलेगा. यू विल गेट 1 to 6 में से कोई एक मिलेगा, बट क्या मिलेगा? हर किसी का लाइक्लीहुड सेम है. लाइक 1 की भी
Right.
लाइक्लीहुड उतनी है जितनी की 6 की लाइक्लीहुड है.
Right.
तो अब वो मैं पूछ रही हूँ कि वो लाइक्लीहुड कितनी है. जैसे कॉइन में तो 0.50 है, इन केस ऑफ कॉइन 0.50 है. डाइस में कितनी होगी, या डाई में कितनी होगी? कुछ नहीं, 100 को 6 से डिवाइड कर दो. 100% को 6 से डिवाइड कर दो. Whatever comes out to be, it will come out to be what, 16.66 or 16.33. It's what, 40, 36, of course, 16.66. So 16.66% is the chance of each number, and if you add 16.66 6 बार ऐड करोगे तो आपके पास 100 आ जाएगा. 99 point something आएगा, which you can round off as 100. Is this example clear?
Absolutely.
I love this word. Okay, complementary events. Complementary, of course, something which goes hand in hand, something that sorry. Sorry. When two things are having are going on side by side or together, so then we call it a complementary event. So if this complementarity or complementary events will happen only when you have got mutually exclusive events. So when you're having mutually exclusive coins, uh, uh, one event will be complementary to the other one. So like if you are having if you're rolling a die, and if you remember your Ludo games, which of course Corona made very popular, so we know that यहाँ पे यदि if this is 1, पीछे वाले साइड पे क्या होगा? 1 के ऑपोजिट साइड क्या होता है डाई के?
6.
6, very good. फिर ऊपर क्या आएगा? 2 के पीछे क्या आता है?
That's 4.
ठीक है. And 3 के पीछे 5 आएगा. तो ये these are complementary events. These are complementary. So generally, people don't give you the example of a die. They give you an example of a coin because that's much easier to understand because it's just two events that are there. So both are complementary. So in case of a die, a lot of people say that all of them are complementary. No, they are not. All of them are not complementary. It's like if I'm throwing 1, then 6 is complementary to it. If 3 comes, then 5 is complementary to it. If 2 comes, then 4 is complementary to it. So that is what complementary events are, right? And please correct me, all the mathematic genius who are here. Simple and compound events that you have. Again, now simple and compound events, if you want to understand, uh, if there is a single event, or if there is like rather experiment, instead of using the word event over here, where is my pen? Okay, instead of using the word events over here, I should be using the word experiment. So if I am carrying out a single experiment, then it will be a simple event. Okay, so if I have got, say, I've got one coin, I've got one dice, I've got one pack of cards. So these are all single experiments. These are all single experiments that are happening. And when I'm having single experiments, then there will be simple events to it. On the other hand, if I am tossing, say, uh, two coins, I'm tossing 2 coins simultaneously, or I'm tossing 4 coins simultaneously, then this becomes a compound event. This becomes a compound event, right? So when you're doing the same experiment, the experiment is not changing, only is that you are doing it in multiplicity. You are doing it in multiple times, like you are having different coins, and you have got 4 people who are tossing the coin at one go, and you are recording the results. And in the simple one, you are just having a single coin. I myself am doing it and trying it out. So that is a simple event, right? So acha, uh, right now Wimbledon is going on, and before every match there's a toss of the coin to choose which side they'll take, or who'll serve first. If there are if there are 10 matches going on simultaneously, if there are 10 matches which are going on simultaneously, and they are starting at the same time, the coins are being tossed at the same time, is it a simple one, or is it a compound? Is it a simple event or a compound event? uh, hmm,
Simple event, single event.
single, not compound.
No, because 10 coins are tossed for the 10 matches, I guess.
हाँ, तो वो सिंगल होगा कि कंपाउंड होगा?
I mean, single for one match. I mean,
हाँ,
one
but
first
but
coin
10
is
coins,
tossed.
but 10 coins are being tossed simultaneously.
Yes, 10 coins are tossed simultaneously, but for 10 events, like 10
Hmm.
different events.
Hmm.
So
So it is simple or compound?
it's simple. If 10 coins are tossed for one event, then it will be compound. I mean, this is purely
Hmm.
guess.
अक्षय, मैथमेटिशियन, भाई इंजीनियर साहब बताएं.
Both the events are exclusive.
Hmm. Yes,
They
they
are
are
not
mutually
related to each
exclusive.
other. They are not related to each other, so it's a simple event. There is no
Yes,
relation.
right. So Akhil gave the right answer. I was just trying to confuse him. Uh, all though there are 10 coins being tossed, but they're all mutually exclusive. So that is how it works. All right. So Mm. Now, there are approaches in probability. There are approaches. So we talk about the prior approach, the classical approach, and here they what the assumption that with which they are going is, the assumption is that all possible outcomes of an experiment are mutually exclusive and they are equally likely. So all of them are one is not dependent on the other, and all of them have got equal chances. So if that is the case, then that is a classical approach that is there. And so here, how do you calculate the probability of event? So number of outcomes favorable to occurrence of E upon total number of outcomes that you have. So like we say that head, which is like I tossed a coin once, uh, tossed the coin once, and I got head. uh, so this is 1, and the total number of outcomes are 2, that is head and tail. So this comes out to be 0.5. In case of if I'm rolling a dice or a die, then I get again 1, like it's not the number 1, but I get one thing, and there are total number is 6. So that comes out to be point um, what 10 divided by 6 is what, 1 point, a point 1 66 0.16, right? So that is 0.16. So this is how you measure your probability. Any doubts so far? Anything that you have not understood? Everything is clear. Check. Now we are talking about fair coins, fair decks. Uh, that means what we are trying to say in the classical approach is that uh, everything that is happening, there are no like there is no bias. What you're trying to say is that there is no bias here. In actual life this doesn't happen, because when you are using probability in real life, there is a lot of bias that is happening. There can be a lot of retained information. A lot of things can be there which impacts your probability, right? And in order to determine probabilities, no coins had to be tossed, no cards shuffled, that is, no experimental data were required to be collected. So they said that you just you need not carry on the experiments, just like that you can find it out, which is not so true. Now then we come to the empirical approach, or the relative sequence approach, which we use a lot. And this is saying that it uses the relative frequencies of past occurrence as the base of computing present probability. And of course, as the name goes, empirical means that where you're doing something. So when you are conducting an experiment, actually when you are going out and doing something, so that is known as empirical approach. And we say that so here the word that comes is trials. So we say that you're doing trials. That means you're doing something again and again and again and again, so that iterations are there. And if an event has occurred r number of times in a series of n independent trials, all under uniform conditions, then the ratio of r gives the probability of event e, provided n is sufficiently large. So favorable trials upon total number of trials. Can somebody give me a very quick example where we use this in real life? Very quickly. Somebody can give me an example that where do we use it in real life? Hmm. Please.
A COVID test.
Hmm.
So, like in a day, favorable trials are like positive, and total
Well,
tests are done.
okay, right. So, the number, like, how many tests have you done? The COVID tests you have done, and so that will be the total number of trials, and
Yeah.
how many positive cases you found out. So, positive divided by total tests conducted. This is what you are trying to say?
Right, ma'am.
Right. So very good. This is a absolutely right example. मेरे दिमाग में जो एग्जाम्पल चल रहा था, लेट मी शेयर दैट विद यू एज वेल. मेरा कोविड पे बिल्कुल भी नहीं था. मेरा था कि लाइक व्हेन वी डू क्यूसी, व्हेन वी डू क्वालिटी चेक्स, there also we like when we want to find out the probability of defective pieces, or when we want to find out the probability of defects in your manufacturing. So there also we like we conduct the trials, that how many are there, and then you find out the number of defects upon the number of checks that have been done. So that this was the example that came to my head. This is an absolutely good example, absolutely wonderful example.
This one good example, and even mine was the from the real life.
हाँ, absolutely, that is what I'm saying. Yours was absolutely right. So मेरे दिमाग में वो आया था, डिफेक्टिव वाला आया था, पता नहीं क्यों. Though I'm not into production. Uh, so, but yeah. Right. So now this is based on the intuition of the people. It's not scientific. This is the third approach that we are having, the subjective or the intuitive or the judgmental approach that we are having. So we generally use this one, the empirical approach we use the most. And this is, of course, because it is based on individuals intuition. So of course there is a big bias or subjectivity enters. So whenever subjectivity enters into your analysis, then it becomes not a scientific approach, obviously, because there's subjectivity there. Then comes the laws of probability. Okay. Now, when you're talking about the laws of probability, so we say that we have already established these things. We say that it is in percentages, ratios of fractions. Generally, we use percentages to tell the probability, because that's easier to understand. Everybody understands percent. And each event has a complementary event. So PE1 plus P dash E1 is equal to 1. So every event we are saying has a complementary. And then you have got marginal probability, union probability, joint probability, and conditional probability. So these are the four ones that you're talking. So let's look at what marginal probability is. This is unconditional probability, or of something occurring or not occurring. So it is rather it is unconditional probability. That means there is no conditions that have been there. So there are no control variables over here. So no conditions, nothing. And so number of outcomes favorable to the occurrence of E upon total number of outcomes. So the example that he gave about COVID, positive cases upon the total number of tests. So that's here for you. Then comes union probability. Now union, if we are talking about union, so like if you have your Venn diagram, so यूनियन वाला हिस्सा कौन सा होगा? पूरा होगा कि केवल ये इंटरसेक्शन वाला हिस्सा होगा? The green part or just the blue part?
A green part.
Absolutely right. Absolutely right. यूनियन का मतलब है प्लस एंड. तो जब when you are adding or and you are doing, so that means the entire thing you're saying. So that is union. So remember your Venn diagrams. And here we are saying that so we use this symbol of union. This is the symbol of union. So again, go back to your Venn diagrams. And uh, it is a probability that event E1 will occur, or that event E2 will occur, or both events will occur. So here this word and comes in. So the one that I was talking here. So probability that a person either owns a Maruti 800 or Maruti Zen. So here, if we are taking this example that he either owns a Maruti 800 or a Maruti Zen. So for qualifying to be a part of the union, you have to have at least one of these cars. So either you have 800 or you have Zen, or you can have, of course, like this, if the intersection part says that you are having both. But to qualify for the union, you have to have at least one car. Is the example clear? Is this example clear? हाँ ना, ठीक है. I understand that it's how much. Okay, so I've been speaking for the past 1.5 hours. Almost 90 minutes. I know it's a bit exhaustive. Joint probability we are talking about. I took it as a yes there. Joint probability is here. This is the intersection part. This is the intersection part. So here we are talking about this the blue part. So we will be talking about this blue part, that means which is common to both. So here the example, again we are taking the same example, the probability that a person owns both. Now here we are saying owns both. In the previous case we were using the word either. So either or we were using. Here we are using both. So that means only this portion here, these people are having 800, these people are having Zen, and these are the few people in between who are owning both the things. So that's a joint probability. So if you remember again your Venn diagram, you used to write it as A intersection B. So this is what we are doing here. Then comes conditional probability. So the marginal probability, if you remember, marginal probability was unconditional. That means you are not putting any conditions. Here, conditional probability you're talking. So you are saying that conditional probability of two events, E1 and 2, is generally denoted by P E1 upon E2. So here the condition is that event 1 will occur only and only if event 2 has already occurred, right? So if I want to take an example of this, then like if we continue with the same example, we say that conditional probability is a probability that a person owns a Maruti 800 given that he already has a Maruti Zen. So this is the condition that you are putting in. Somebody wants to enter the class right now. For how many minutes? Uh, okay. Mm, mm, no, acha. Right. So here we are saying that you are so this is the condition that you are implying, that Maruti 800 होगा यदि Maruti Zen है तो Maruti 800 है. So this is the condition that you are putting in. So that is conditional probability. Then comes your addition rule. This is the addition rule, and then we'll be looking at the multiplicative rule, and then we'll end the class. So there are two events, E1 and E2. So this is your addition rule. So PE1 plus PE2 minus PE1 and E2. So you are taking all 800 people, you are taking all Zen people, and you are subtracting people with both 800 and Zen. So you have taken people with Maruti 800, you have taken people with Maruti Zen, you have added them, and you are subtracting those people who have got both 800 and Zen. If the events are mutually exclusive, that means one is not dependent on the other, then this intersection wala hissa nahi hoga. It'll be simple PE1 plus PE2. So if it is a mutually exclusive thing, so I say Maruti 800 and then I talk about Bajaj Pulsar, and both of them are mutually exclusive. So then I just add these two. Fine. Is it clear? Is the addition rule clear when it is not mutually exclusive? Like this is a general rule and this is a mutually exclusive thing. Is it clear? Chalo. People have gone off for their dinners.
Yes, ma'am. Clear.
Yeah, multiplication rule. I'll just end it here. That if there are two events, E1 and E2, then the general rule of multiplication is again. Now here, please pay attention to this, that it is probability of event 1 times, that means you're multiplying probability of okay, uh, you are multiplying it by the probability of this thing, right? The probability of E2 upon E1, you are taking it. And if the events are independent events, right? So they are not depending on each other, independent events are there. Then you have PE1 and E2. So you just multiply those things. Please remember that pay attention to these signs. These are very, very important signs here. This sign and this sign. Here, if you are adding them, and means union. So this is E1 union E2. So then your E2 goes up, because here you are saying that E2 will happen, and that. And here, अच्छा दोनों सेम ही है, चलो, okay, no issues. Right. So I suppose I'll stop the class here. And because it's 8:07, I've been speaking for more than 95 minutes, and I'm not getting the responses also. If you have any queries, I'm just giving you 2 minutes break. You can just take a water break. Let me also take a water break. And All right. So, uh, any doubts anywhere, anything that you people have not understood? Uh, you want my clarification? In the distribution thing, please remember when we are talking about probability distribution, it's the normal distribution which matters the most, the normality. And Poisson distribution, if I can just put on my camera, and if I can just uh, go to my window. Poisson distribution is something which is it is many people say that it is very similar to binomial, but the basic thing is that Poisson measures very small changes. So like when you are talking about Poisson distribution, it takes uh, discrete, of course it's a discrete thing, and it takes a very small changes. So like when we want to look at the distribution of things where minute changes also matter, like say temperature, say the axis of the earth. So in physics they use a lot of Poisson distribution. In social sciences, what we are concerned with is mainly normal distribution. So we are very much concerned with normal distribution and how things happen. So this is binomial. Binomial obviously means two. You have got if you're talking about two things, so that is basically two mutually exclusive outcomes you are talking. And if you want to plot that and you want to look at that distribution, then that is a binomial probability distribution. Bernoulli process is there for that, and there is a particular way of doing it. So people who are familiar with this permutation combination, so you understand this formula, which is there here for you. So people who have studied mathematics, so you understand this permutation combination wala formula, and you can say this is like n factorial upon x factorial times n minus x factorial that you have. As I said, that what we look at is mainly normal distribution, because that is what we are concerned with. Now in normal distribution, we say that mean is equal to median is equal to mode. So this is how it looks like. Your normal distribution is, this is how it looks like. So there is no skewness. We say that there should be no skewness. So skewness means what? Like if my data is like this, if it is having one long tail, or my data is my distribution is coming out to be like this, then these are skewed things. So it has to be normally distributed. It has to be a perfect bell shape where mean is equal to median is equal to mode. uh, of course, when you are talking about, so this we have already studied. One standard deviation, we said 68%, 97%, and 99.7%. So the two tails are asymptotic there. Mean, mode, median are identical. So you've got symmetrical or mesocurtic thing. We are not going into kurtosis. Like you have got leptocurtic, mesocurtic, and plutocurtic. These are basically, that's the height. ये और कुछ नहीं है, मतलब इसको इतना बहुत ज्यादा नहीं. Yeah, if you look at in the books also, if you look at the kurtosis diagram, then they have a kangaroo over there. So it's just the hump. Like when you're drawing this normal distribution wala curve, so this hump that is there, that is measured by kurtosis. So it has to be symmetrical. It has to be mesocurtic. So that means it should not be too long, or it should not be too short. Height should not be too much, should not be too less. It should be in the middle somewhere. And yeah, so this is what we are talking about here. And I suppose I'll stop my class here. I'll if you people have any doubts, you can come forward. Otherwise, I can request Dr. Gargav that we can end the meeting here. Mm. Any doubts? Any questions? Anybody? Anybody who's having any? Yeah, Bidisha, go ahead.
Ma'am, this multiplication rule,
Yeah.
I think I I got a little lost over there.
Okay, in the multiplication rule, that what you are trying to do is you are trying to find out the intersection area basically. When you are trying to find out the intersection area, let me go back to my thing so that it becomes a bit easy for you to understand. So here what we are trying to find out is that this is the multiplication rule that you have, and so you are taking the probability of E1, event 1, and then you are multiplying it with this, you're taking event 2 upon event 1, so which is basically the intersection part you are taking there. And this is how you calculate it, like you divide, and you that is how you get it. And sorry for it, because the cook is here, so like cooking is happening. So I'll share this PPT as well with you, so that you people can go through it. Vidisha, I'll share it with Dr. Gargav, and then she can share it with you people.
Okay,
Is it
ma'am.
okay? Yeah, yeah,
One
I'll do that.
thing.
Yes, yes, go
Uh,
ahead.
it, it is written TE1 and E2. It means that both the events are
Events.
occurring together.
Yes, 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 yes.
Okay,
There are
okay,
both the
ma'am.
events are there, right? Because
Okay,
addition and multiplication, there has to be more than one event.
hmm. Okay, ma'am. Thank you.
Right, right. Dr. Gargav, I suppose there are no more questions, and I'll be sharing my PPTs with you, and you can further share it with the students here, with the participants. Mm, I'll do one thing. One is I'll stop recording